Welcome to the Explainer. Today we're unpacking some seriously incredible engineering, Google Cloud Spanner. If you've ever wrestled with a database that just flat out refused to scale without putting up a massive fight, well, you're going to absolutely love this because Spanner fundamentally rewrote the rules of distributed data. We've got a packed agenda today. We'll start with the massive headache of manual database sharding, then jump into Spanner's POXes architecture, explore how TrueTime masters global consistency, and finally, look at how the Resi storage engine evolved. Part 1. The problem with manual sharding. Okay, so to set the stage, let's quickly touch on the traditional workaround, database sharding. As data volume just explodes, we're talking an estimated 175 zettabytes globally by 2025, single databases just buckle under the pressure. So, sharding steps in to split that massive database into smaller, bite-sized pieces, or shards, and spreads them out across multiple servers. We all know the drill here. Vertical scaling, it eventually hits a rock-hard hardware ceiling. Horizontal scaling, on the other hand, gives you massive capacity by distributing data across servers. But man, it introduces some immense, chaotic complexity right into your application logic. To really put this pain into perspective, let's look at Google's F1 ads backend. They were dealing with tens of terabytes of uncompressed data on a manually sharded MySQL database. It was so complex that the app logic literally had to know exactly which shard held which customer's data. And get this, their last manual resharding took the team over 2 intense years of coordination. Seriously, 2 whole years just to reorganize data. Section 2. Enter Spanner and its Paxos architecture. So to fill that massive 2-year bottleneck of a void, Google built Spanner. Notice how the span server stack is deployed across multiple zones. This isn't just your standard load balancing, we're talking unparalleled high availability here. If an entire zone completely goes dark, the database stays up and running without anyone lifting a finger. But that begs the question, how do all these scattered zones actually agree on what the data is? Well, Spanner uses Paxos. It's a highly reliable consensus protocol where one zone's replica is dynamically crowned as the leader to handle write transactions for a specific chunk of data, while the other replicas safely take care of the reads. Seeing this Paxos state machine in action is pretty fascinating. You've got transaction managers and lock tables constantly syncing up between the leader and the replicas. This is what guarantees absolute fault tolerance. If a leader goes down, no panic. The replicas use Paxos to negotiate a brand new leader almost instantly, and the whole system just keeps humming along. Section 3. TrueTime and Mastering Global Consistency. Now, this brings us to a massive physics hurdle. In traditional setups, you literally lock the database to maintain ACID compliance and guarantee transaction order. But when you're operating at a global scale, locking the whole database absolutely kills performance. What you really need is external consistency, meaning if transaction A commits before transaction B even starts, transaction A has to get an earlier timestamp, globally, without creating a massive bottleneck. Sounds impossible, right? Well, Spanner solves this with its TrueTime API. TrueTime cross-references 2 completely distinct time sources deployed at all their data centers, GPS and atomic clocks. Now, why use both? Because they have completely independent failure modes. GPS can get messed up by radio interference, while atomic clocks suffer from natural hardware degradation. By running a variant of Marzillo's algorithm to cross-reference them, TrueTime basically weeds out the liars to find the actual true time. But hey, no clock is perfect. There's always going to be some clock drift. So instead of giving a single rigid timestamp, TrueTime gives an interval of time that includes a bounded window of uncertainty. And thanks to Google's specialized hardware and network, that uncertainty interval is incredibly tiny. We're talking just 1 to 7 milliseconds. So if you have this tiny millisecond window of uncertainty, how do you stop 2 transactions from getting jumbled up? The solution is honestly beautifully simple. Spanner just waits out the uncertainty interval before committing. Because the interval is so incredibly small, the lag is practically negligible. But the payoff? A strongly consistent, perfectly ordered viewpoint of time across the globe. Which brings us to Section 4, Resistance, and the evolution of the storage engine. Let's finally look under the hood at the literal foundation where all this data physically lives. The industry obviously started with single-node databases. Then Google moved to Bigtable, which used SS tables, basically just untyped sorted string tables. But today's applications demand complex schemas and strong consistency. So Spanner evolved past those SS tables to the brand new RESI storage engine, bringing strongly typed relational SQL to a massive distributed scale. It's a really clear evolution, migrating away from the tangled mess of untyped string tables toward the shiny new RESI engine. This wasn't just a minor update. It was a monumental shift from a basic key value store mentality to a true, fully SQL native representation. And the scale of this transition? Absolutely staggering. To pull off RESI, Google successfully executed a live migration of 8 exabytes of data. 8 exabytes! Today, this powerhouse engine supports multiple billion user products and handles an aggregate of over 2 billion queries per second. It gives you the declarative power of SQL paired with those ironclad ACID transactional semantics you'd expect, all at a scale we used to think was just impossible. So by combining Paxos for fault tolerance, TrueTime for global consistency, and RESI for strongly typed storage, Spanner fundamentally changes the whole database game. Now that the absolute nightmare of manual sharding is solved and exabyte scale is unlocked for relational data, the only question left is, what impossible application are you going to build next? Thanks so much for joining me on this explainer, and I'll catch you in the next one.